The screen is visible, right? You can see the screen.
Yes, sir.
Okay, okay. Okay, in the last class, we studied about various components of the carburetor. What is a carburetor and its components? And we're discussing about the components itself. And we had studied up to metering system, idling system, and then float chamber. Okay, till float chamber I took yesterday. Then in the next component is the mixing chamber. So the mixing chamber is this part of the carburetor. So when you look at the schematic diagram itself, so this is the schematic diagram. So in the schematic diagram itself, the place where the fuel and air mix with each other or forms the mixture known as charge. It is called charge. So this charge is formed in the mixing chamber. So in the mixing chamber, the fuel and air gets mixed in a carburetor. Okay, in the mixing chamber. So that is the function of the mixing chamber. Chamber is the place where the fuel and air gets mixed. So you can see the incoming air from the atmosphere, which is sucked into the engine, and this comes through the carburetor. And here the fuel enters through this part and falls into the float chamber. And from the float chamber, it evaporates into the mixing chamber. This is the mixing chamber. So in the mixing chamber, you can see the fuel particles and the air molecules are mixed together and then passes through the throttle valve. Okay. Next component is the idle and transfer port. So we saw the idling system, and at that system itself, there is a port. So this is the port that is coming here. There will be a port here. And through this port, it will go beneath the throttle valve. So such a port is shown here. So this is that port here. You can see two holes here. There are two holes here that are the transfer slots at idle. So through that only the fuel and air mixture comes out. Okay, this is the throttle. Here it is showing the throttle part. This is the butterfly valve, and it is in an inclined place. So it is in a slanting this way. So when it is closing, it will not be closing horizontally, rather in an aligned manner. Okay, that is what is shown here, and you can see the holes here. These are the transfer ports or the idle ports through which at the idling condition I have explained it before, that is when the vehicle is at rest but engine is running, preferably at the traffic signals and all. Okay, or when you are going to stop a vehicle itself, you put the gear in the neutral position, and then the engine is still running and the car is on, but the engine is not switched off. Okay, the car is at rest. So at that time, through this port, the air and fuel particles enters into the cylinder. Okay. Next is the choke valve. So the choke valve is present. This you can see in the schematic diagram. The choke valve is present on top of the throttle valve. Okay, the choke valve comes first, then comes the throttle valve. So the function of choke valve is to control the mixture of air and fuel. To control the mixture of air and fuel. So you can see that in the schematic diagram. You can look here. So the fuel and air mixture mixes and enters into the mixing chamber. So this is the mixing chamber, and in the mixing chamber, the throttle valve is present. So you can control the amount of charge entering into the cylinder using throttle valve, which is connected to the accelerator pedal. Okay, so by moving the accelerator pedal, you're controlling the throttle valve, and the throttle valve controls the amount of charge entering into the cylinder. It only controls the charge entering into the cylinder. So if you want to reduce the amount of air entering into the chamber, we use the choke valve. Okay, choke valve controls the air entering into the carburetor or the carburetor mixing chamber. Okay, that is a function of choke valve. So in turn, if the choke valve is closed, air will not be coming into the carburetor. But normally it does due to the idle port and transfer port I have shown you earlier. So it will come, but if the choke valve is partially closed, partially means not fully closed, partially closed, then less amount of air only enters into the mixing chamber. And if it is completely open, more amount of air will enter. Okay, that is the function of choke valve. So what will happen, why the choke valve is provided? So you can see in the winter season when the engine is not starting, we use this valve to get a rich supply air fuel mixture to the engine. So what is a rich air fuel mixture? Rich air fuel mixture is nothing but the fuel molecules are greater than air molecules. When more amount of fuel is present inside the charge when compared with air, then it is called a rich mixture. So during winter season, there is something called as a cold starting. So the air temperature is very low so as ignition will not happen inside the cylinder. Okay, such case we don't have in Kerala, but in colder countries such as even in our northern Indian positions such as Jammu and all, so there is a winter season. So in the winter season the problem is that the engine will not start properly due to the cold temperature of the air. So once the air is hot inside the cylinder itself, combustion can occur. Okay, combustion can occur only when the air is very hot, and that hotness will be transferred to the fuel, and then ignition will happen. This I will tell you in a later class. But due to that condition, we have to provide more fuel so as to give more temperature. Okay, so if that fuel, more fuel is there, if you are igniting that fuel, we will get big temperatures. So for that, for the attainment of that temperatures, we provide rich air fuel mixture. And how do we give rich air fuel mixture? When we close the choke valve, okay, when we are operating the choke valve, what we are doing is we are closing the choke valve. So in the normal position, the choke valve is always in the vertical position, that is completely open. So when you adjust the choke valve knob, we are adjusting by closing the choke valve or the pathway of the air. So what happens is that the air entering into the mixing chamber will be less when compared to the fuel evaporated into the mixing chamber. So we will get a rich mixture. So this is how the choke valve is used in a carburetor. Okay, now I will tell you the working of a carburetor. So how does a carburetor work? So here some components are given. So this is the air entry. That is one. Point number one. What does it say? Air flows into the top of the carburetor from the car's air intake, passing through a filter that cleans it of debris. So first, what you're doing is the air will come inside the compressor, and the air is flowing through the carburetor through the first point, that is the choke valve position. So at that time, the air is cleaned by using an air filter and it flows into the carburetor. So this is the point number one. Second point, you can see the second point, we have shown the choke valve. When the engine is first started, the choke, which is in the blue color, can be set to almost block the top of the pipe to reduce the amount of air coming in, increasing the fuel content of mixture entering the cylinders. So once to provide the engine to its optimum temperature, that is 200 degrees Celsius. So the engine at rest, that is when you're starting an engine, it may not be that hot as its normal operating temperature, that is 200 degrees Celsius. So it will not reach to up to that degrees at first. At first, it will be equal to the room temperature or the atmospheric temperature that we experience. And once it starts and a few cycles of combustion take place, it attains the temperature 200 degrees Celsius. Okay. To attain that, first we have to provide a rich air fuel mixture. For that purpose, the choke valve is partially closed. So it almost blocks the top of the pipe. Almost blocks the top of the pipe. So after that, the rich air fuel mixture enters into the cylinder. Okay. So let's look at the third portion. In the center of the tube, the air is forced through a narrow kink called a venturi. So I have told you before, venturi is nothing but a pipe wherein the cross-sectional area decreases than the original cross-section. So this is the original cross-sectional length you can see, and it decreases into a narrow area shown here. Then again it increases, okay, into the bigger cross-section. So this is the venturi, okay, and this makes it speed up and causes its pressure to drop. Okay, what happens is that when you reduce the area, same as that of a garden hose, so you have all watered plants. So when you are watering plants, we use a garden hose, and to get larger distance, what you do is you just block the pathway of water using your hand or finger. Okay, while you are blocking that passage or that hole a little, sufficiently the speed of the water increases. Okay, the speed of the water increases. In the same way itself, in venturi, when the cross-sectional area is decreased, the speed of the air increases. So at this portion, the speed of the air will increase. And once the speed increase, there will be a pressure drop. Pressure drop is nothing but the pressure decreases. Okay, once velocity of the air increases, pressure decreases at the throat position of the venturi. At this point of the venturi, the pressure drops. And when the pressure drops, what happens is that the fuel is present at atmospheric pressure. Atmospheric pressure is the pressure where atmosphere exerts onto the fuel. So the fuel or any particle in the atmosphere always contains atmospheric pressure. Even our body itself is at atmospheric pressure. So when a pressure drops happen across this throat position of the venturi, what happens is that the pressure is lower here and the pressure will be higher here. So the atmospheric pressure will be higher than the pressure drop forming here. So due to that, always pressure uh, follows or passes from high region to low region. It passes from a region of high pressure to a region of low pressure. So since atmospheric pressure is higher here, the fuel at atmospheric pressure passes into the area of low pressure. Okay, when this happens, the air and fuel, the fuel will be sprayed here. Okay, the fuel will escape through here through a nozzle, which you can see. Yeah, here you can see the nozzle here also. And in the schematic diagram, you can see how the fuel is escaping here. You can see a few dot droplets of fuel. So that will be mixing with the air at the venturi. Okay, so that is how fuel is escaping from that point. Then the fourth point was what I called the drop in air pressure creates a suction on the fuel pipe. That is the fuel pipe shown here, drawing in fuel. That is orange. So how the fuel escapes into the throat, I explained earlier. Next point, you can see the throttle green is a valve that swirls to open or close the pipe. It swirls to open or close the pipe. So this is the throttle valve that is shown in 5. So what is its function? To control the air and the charge that is entering into the cylinder. To control the air plus fuel mixture, that is called the charge. To control the charge entering into the cylinder. That is the function of throttle valve. When the throttle is open, more air and fuel flows to the cylinder. So the engine produces more power and the car goes faster. Okay, that is what is happening in fifth gear. So we are giving more accelerator, and to give it at a high speed, we are opening up the throttle a bit more than the previous condition, so that more amount of charge enters into the cylinder and the vehicle goes faster. In the sixth point, you can see the mixture of air and fuel flows down into the cylinder. So this is going then into the cylinder. That is the sixth region. The seventh region, fuel is supplied from a mini fuel tank called float feed chamber. So this is the seventh portion. From the float chamber, it escapes into the fuel discharge nozzle, and through the nozzle, it escapes into the venturi. Okay, that is the seventh region. And in the eighth region, you can see as the fuel level falls, a float in the chamber falls and opens a valve at the top. So at this eighth region, that is a float chamber, you can see the float here. This is a float, a crude depiction of the float. You can see the float here itself. Okay, it will be something like this, or most commonly it is like this in the shape of this carburetor part. It's the float. I'll show you a video later. So it will be like this. Okay, the float will be like this, and there will be a needle valve on top. So once the fuel starts escaping here, the amount of fuel will become less and less. And once that happens, the float moves downwards. Naturally, it moves downwards. And when that happens, the fuel enters through this strainer and this orifice, and it falls into the float chamber until the float needle valve closes this point. Until it closes, the fuel will flow into the float chamber. So that is what it is said in the eighth region. Then in the ninth region, when the valve opens, that is here, the valve here, when that opens, more fuel flows into replenish the chamber from the main gas tank. This makes the float rise and close the valve again. So in the eighth region, what was happening? Fuel gets less and less, and the level of fuel comes down, and the float naturally comes down. Then in the ninth point, it is saying that then the valve, the needle valve that is shown here, will open, and from the main fuel tank, that which you are filling at the petrol station, from there the petrol then falls into the float chamber due to this opening of the needle valve. So once the needle valve opens this passage, fuel flows into the float chamber, and the float thereby rises and then again closes this path. Okay, that is what is done in the ninth region. So that is the working of the carburetor. So you can see here the working itself. So this is the choke valve, this is the throttle valve, and you can see how the air is flowing here. So you don't have to worry about this part. This is another part. It's called various circuits are present at the carburetor, which you don't have to study. You just have to know how the working of carburetor is. So this is the float chamber here. You can see the float chamber here. There is a float here. Here there is petrol or the fuel that is stored here, and it is escaping here. You can see the small point here. Okay, so you can see small droplets of air coming inside. There is some few particles coming here, and it is mixed with the air. This is a throttle valve, choke valve. So choke valve is always open. So instead of controlling the choke valve, we are controlling something called, this is a diaphragm, or this is a centrifugal type of diaphragm. This is, you can see here, the idle port and all, it's provided here. Okay, the idle port and all, it's provided here. It is below the throttle valve, and through which fuel and air can escape into this point. So this is another circuit. So just for an understanding only, I provided you with this video. So you can see how the air goes into, once the throttle valve is fully open, the air flows very fast inside and you will get more power during that portion. So you can see how fast the air and fuel particles move when the throttle valve is completely open. When it's partially closed, you can see how slow the air and fuel particles move into the cylinder. Okay, this is the working of the carburetor. The main functions of the carburetor are: first is to mix the air and gasoline to provide high combustion mixture. That is one of the main function of the carburetor. Mix the air and gasoline for the combustion mixture, that is the charge. Then it controls the engine speed. It controls the engine speed by means of the accelerator pedal, which is connected to the throttle valve. So the throttle valve is adjusted to maintain the engine speed. It also regulates the air fuel ratio. So the air fuel ratio is controlled by the choke valve. Okay, the choke valve determines how much air enters into the cylinder. So if the amount of air is less, it will form a rich mixture, and when the amount of air is more, it forms a lean mixture. A rich and lean mixtures, two mixtures, and this is due to the functioning of choke valve. Okay, then the fourth point, it increases or decreases the amount of mixture according to the engine speed and load changing conditions. So that is also done by the throttle. So when we are at low speeds, we will give more throttle. At lower high speeds, we will give lower throttle. So that is also controlled by the carburetor by means of the throttle present inside the carburetor. Then the fifth point, to keep certain head of fuel in the float chamber all the time. So this is maintained by the needle valve and the float valve assembly. So the float valve and needle valve forms a part in which the fuel during the decreasement or the decreasing amount of fuel, more fuel enters into the float chamber, and once the fuel reaches up to that level, the float itself by means of the needle valve closes the pathway for more incoming fuel. So the fuel is then blocked. So this is how the float and needle valve assembly does in a carburetor. Then the sixth point, vaporize the fuel and mix to air to form a homogeneous air fuel mixture. So what is a homogeneous air fuel mixture? In a homogeneous air fuel mixture, once we are mixing the mixture, if you take one part of the mixture and another part of that mixture, small portions of that mixture itself, you will see that the amount of air and fuel present inside that mixture, or the ratio of air and fuel present inside that mixture, will be equal at every portions. So if you are taking at each and every portion, it will be equal. The amount of air fuel ratio will be equal. Okay. But in a heterogeneous mixture, at each point, different air fuel mixtures or different air fuel ratios will be formed, and that is undesirable. So we have to mix the air to form a homogeneous air fuel mixture. That is the function of carburetor. One of the function of carburetor, to mix and form a homogeneous air fuel mixture. Then the seventh point, to supply the correct amount of air fuel mixture at the correct strength under all condition of load and speed of the engine, to provide correct amount of air. So at each condition, so you have gear conditions. So each gear at the topmost gear, that is the fifth gear, we require only less air fuel mixture because more air fuel mixture, but lean mixture. Lean mixture means wherein air is greater than fuel particles. Okay, air is more than fuel particles. Such a mixture is called a lean mixture, and at high speeds, lean mixture is only required, and more amount of lean mixtures are required for sufficient speed. But in lower gears, that is the first and second gears, we need a rich mixture wherein the air particles will be lesser than that of fuel particles, and that such a mixture is known as a rich mixture, and that mixture is needed for first and second gear conditions. So to provide that, choke valve is adjusted and we are reducing the amount of incoming air. So this is how the correct amount of air fuel mixture is controlled in engine by means of the carburetor. So these are the functions of carburetor. Next, we will see the fuel injection. So what is a fuel injection? Fuel injection is nothing but the introduction of fuel into the internal combustion engine by means of an injector. So an injector is provided in the engine. This is the injector portion shown here. This is a spark plug. So the injector, so this is a petrol engine rather than a diesel engine. In a diesel engine, instead of the spark plug, only the fuel injector will be present. Okay. In a diesel engine, only fuel injector will be present, not this spark plug. So in a petrol engine, a modern petrol engine, in a conventional engine, there is no injector in a petrol engine. While in modern petrol engine, there will be an injector and also a spark plug. Both will be provided. So the function of injector is to spray or provide fuel into the combustion chamber of the internal combustion engine. So that fuel injection is done by means of a fuel injector. So here you can see the fuel injectors. If you want to see how it looks in the vehicle, this is how it looks in the vehicle. This is the fuel injector. You can see how the fuel injector injects the fuel. Okay. It's suppose here in this type of injector, at its port there will be many holes. So as much as holes there are present, so many streams of or jets of fuel will emit from the fuel injector tip. So this is a tip, and at the tip there are many holes, and how many holes are there, that much jets of fuel you can see or sprays of fuel will come out from the injector. In conventional injectors there are only one hole, but in modern days we are providing multiple holes, which provides more mixing of fuel with the air, better mixing of fuel with the air. So that is the function of providing more holes. So this is how the injector is supposed to look like. So these are schematic diagrams of the injector. So how does what is the function of injector? It provides the fuel in the form of a spray. Okay, in the form of a spray. You are using body spray and all. You can see how the spray comes out from a body spray itself. And in the same way, the fuel injector also atomizes and sprays the fuel into the cylinder or the manifold anywhere. I'll tell you about how the injection is done. So the fuel that is coming into the injector in a petrol engine is used by an electronic system. Okay, it is called electronic fuel injection system. So in that place only we are using fuel injectors in petrol engine, not at diesel engine, while at petrol engine. Normally, the fuel is pressurized here. The incoming fuel is pressurized. So what is the meaning of pressurized? Is nothing but the pressure of the fuel is increased than atmospheric pressure. So the fuel is pressurized beyond atmospheric pressure at a certain value, and it is then passed on to the fuel injector. So what happens here is that the fuel injector, the fuel will come here. So you can see here also the fuel can come till this point. Okay, till that bottom point it can come. So it will be present till here. You can see this thing. It will be present till here. Okay, what in a mechanical or conventional type, this is a mechanical and conventional type, the fuel once it enters this point, and after more amount of fuel is still keep on coming. Okay, it is keeping on coming, and once that happens, the pressure inside the injector rises. So more amount of incoming fuel is still coming on. Okay, it is not same as that of the float valve inside the carburetor. So in the float valve, the fuel is stopped there. Okay. If more amount of fuel is coming into the float chamber, the pressure inside the float chamber will increase and it will burst out. So, but the injector is designed with a heavier metal and a heavier part for such type of failures. So what happens is that the pressurized fuel will get stacked up and it will exert a force against the spring. So that is what is happening here. You can see the fuel exerts a force against the spring, compressing the spring. So once it compresses, the fuel can escape through this part. Okay, can escape through this part, and the pressure will be greater than that of this pressurized fuel. It will be greater than that of the immediate pressure that is given into the fuel injector. So it will be much greater, and due to that pressure, so it will escape through this point, and it can only escape through the hole provided in the injector. So when it escapes through that hole, due to that high pressure, it will be sprayed out. Okay, it will be sprayed due to the high pressure that is formed inside the fuel injector. So that is how the fuel injector conventionally works. And in modern days, we are using electromagnets or electrically controlled fuel injectors, wherein electromagnets are provided here. So you can see this is the electromagnet. So this is the point that the solenoid is also called an electromagnet, wherein the solenoid is a component which uses iron core and a winding is winded upon it. Okay, that is what is a solenoid is, and that solenoid acts as an electromagnet. So once electricity is provided in that magnet, it magnetizes and attracts metals. That is what an electromagnet does. And here also, when solenoid is in off condition, this part of the injector will be present here, which does not allow the passage of fuel. But when the solenoid is turned on, or when the electromagnet is turned on, this part is a metallic part, this part. Okay, this part will be attracted to the electromagnet. That is what is happening here. You can see what is happening here. And once that moves upwards, the fuel is free to move through this part. Okay, the pressurized fuel is free to move through this part, and it will be sprayed from the sprayed tip. Okay, this is how electromagnet fuel injector works. And this spring then returns this metallic part, or it's called the plunger, back into its final position, thereby blocking the incoming pressurized fuel. Okay, this is how electromagnetic fuel injector is done. This is the conventional fuel injector. So fuel injector always atomizes and distributes petrol or diesel evenly. That is a function of fuel injector. Next, there are few types of fuel injection. So there are basically 4 types of fuel injection: single point or throttle body injection, port or multi-point fuel injection, sequential fuel injection, and direct injection. Okay, these are the fuel injection systems that are provided, that are followed in today's vehicles. So I'll take it in the next class, and you just note down these 4 points. Next, I will take the attendance.